Picture this. You're a systems administrator and overnight you get a requirement on your desk. We need to enable all our employees with the ability to work from home as nobody will be allowed into the office for a while. And this solution needs to be active within 5 days. Uh-oh, panic mode. What do? What can you do? I'll tell you. Amazon AppStream is a service to quickly deploy remote desktops with the applications of your choice and deliver the solutions over the public internet, and it can scale very well to hundreds or even thousands of users. Before we jump in, let's see if you have the required skills to get the most out of this course. We'll be using a very specific service in AWS, so it never hurts to brush up on your overall Amazon Cloud basics, which you can do with plenty of other great courses here in the LinkedIn Learning Library. Having a basic understanding of subnets, VPNs, and NAT gateways is certainly useful, but not required. In fact, we'll be doing subnet math, but for that, I'll share a resource with you that can help you get it done without having to worry about binary calculations. Also, it helps to understand the identity store where your users are. The most popular ones are Google Suite in the education sector and Microsoft Active Directory in the commercial sector. These credential management components will play a key role when setting up single sign-on, so it's good knowledge to have. Lastly, AppStream is all about installing software and making it available to others. So it never hurts to be familiar with the software that you're installing to make sure it's working properly before making it widely available. Amazon AppStream is a fully managed streaming service that lets you stream desktop applications to users. AppStream provides users with instant access to the applications that they need with a responsive, fluid user experience on the device of their choice. Users will connect to an AppStream stack using a browser. A stack is presented to the user as a collection of available software applications after they go through a login and authentication process. From there, a secure streaming connection is established with a Windows server that runs as part of the AppStream fleet. This fleet is an autoscaling fleet of servers, all based on the same machine snapshot or image that contains the available software applications. So our job is to create a software stack with the applications needed by our audience and deploy a fleet with enough capacity to handle as many concurrent users as we're expecting. We're also going to need our machine image for the fleet, which we can create using an image builder. Behind the scenes, an image builder is nothing more than an EC2 Windows server with a special software that allows you to take snapshots of the machine after you install applications on it. These snapshots, called images, are then used as a reference for your fleets. This means that going forward, if you need to upgrade software, install new applications, or remove them, it's just as simple as running an image builder, making your desired changes, creating a new image, and updating your AppStream fleet with this new image. It's important to note here that AppStream image builders are based on Windows Server 2012, 2016, or 2019. This is fine most of the time, but you may run into applications that simply aren't compatible with this version of Microsoft Windows. Alright, it's time to start building. Here's what we're going for. A network infrastructure that supports our current requirement with room for expansion in the future. We'll deploy a VPC, a virtual private cloud, and a couple of subnets to host our AppStream fleet. For right now, the public subnet will only be used to host our NAT gateway, and this gateway will be used to provide outbound internet access to our AppStream fleet. Because our fleet will reside in a private subnet, it will not have any public-facing IP addresses, so that's why we need the NAT gateway here. An internet gateway is required here, so we're building that as well. These are the IP ranges we'll be using for our requirement. We'll start by allocating a public IPv4 address in the form of an AWS Elastic IP, which we're going to assign to our NAT gateway. Our VPC will have the range 10.10.0.0/16, which provides plenty of address space for now and for future expansion. By the way, when choosing this range, just make sure that there is no collision with your on-premises network IP range, just in case you want to deploy a VPN in the future. We'll use our first /24 block for our public subnet, 10.10.0.0/24, which means the very next block, 10.10.1.0/24, will be our first private block. One more quick look at our diagram, and we'll start by allocating the IP for the NAT, and then running the VPC wizard to build the rest. Let's go to the console now and actually build this thing. Here we are in the AWS console. I'm going to type AppStream before we get into networking. So I need to show you something. You might get a message that says region unsupported, AppStream 2.0 is not available in US East Ohio. And you can click here and you'll see that the ones that are highlighted are the ones that you can use. In my case, I will use US West 2. The reason why this is important right now is because if you invest a lot of time building a network and infrastructure, and then you realize that AppStream is not going to work in that region, you have a problem and you wasted your time. But now that we can confirm here by moving to US West 2, I can confirm that AppStream works. We get the normal splash screen here. So now we can start with our networking. I'll type VPC and select it. And we're going to scroll down here, find Elastic IP right here. We're going to click Allocate Elastic IP. This is the IP address that we're going to use for our NAT gateway. There's really nothing to do. Maybe perhaps using a tag to give it a name. I'll type name, and then we'll use IP for the NAT gateway. Perfect. And then click Allocate. Now we have our Elastic IP. I'm going to go to your VPCs up here. Confirm that there is no AppStream VPC just yet. And by going to the VPC dashboard now, we can take advantage of using the wizard. I'll click on Launch VPC Wizard. And I'm going to select the second one because I'm interested in a VPC with public and private subnets. So I'll select that and then start here with the select button. If you recall, our range is going to be 10.10.0.0/16. So that's fine there. Let's give it a name. As I just said, AppStream VPC. And now we can go to our public subnet and give it a range here. And that would be 10.10.0.0/24. And that's going to give us, as you can see, 251 IP addresses in that particular subnet. We'll put that in West 2A. And we'll give it a name of pub for public. And then AppStream subnet. Moving on to the private one, that's going to be 10.10.1.0/24, same size. We'll use a different availability zone here. We'll use 2B. Keeping to our naming convention, I'm going to type priv AppStream subnet. And now we need an Elastic IP for our NAT gateway, but we already have that, so we just click here and select it from the pull down. And I believe those are the options. We can click the button here that says Create VPC. That's pretty much it. This process will take a few minutes to complete. Once it's done, we'll verify that everything meets our requirements and double check our routing to make sure it's sending traffic to the NAT gateway. All right, let's verify our results now. That actually completed fairly quickly. So I'll type VPC and get back in there to verify. Let's start by selecting your VPCs. And we can see there's one here at the top that says AppStream VPC, and it has the range we specified, 10.10.0.0/16. Moving on, I'll select Internet Gateways, and let's see here. The one here in the middle, it says Attach, and it's attached to the AppStream VPC. Perfect. Going down the list, let's find NAT gateways, which is really important for us. And there is one, and is attached to, yes, it's to our AppStream VPC, correct? It doesn't have a name, so let's go ahead and fix that. Click on name. I'll type AppStream NAT and save that. Now we have a name. Perfect. Let's see our subnets now. Click on subnets here on the menu sidebar. And I'm going to type AppStream here to simplify this listing. And this way we get the two that we created. We can see them here. Perfect. Let's go now to route tables. So I want to verify that these two subnets are routing properly. So I'll select route table from the menu. And let's see, I see two of them. Perfect. I'm going to click on one and select on subnet association. I see 10.10.1.0. That's our private one. And let's see if it's actually doing what it's supposed to do by clicking on routes. And we see that there's a local route, the 10.10.00/16. This is correct because this means that anything in this subnet can talk to anything within the VPC. So that local route is expected to be there. Following that, we have the default route, which is a 0000, and that one is pointed to the NAT gateway. This is perfect because anything that you deploy in the private VPC is not going to have a public-facing IP address, so it cannot reach the internet gateway directly. It needs to do it through a NAT gateway, as we can see here. Let's verify the other one. That would be the public subnet. And as you can see, it also has the same local route in the route table. But this time, the default route, the 000 route, is pointed directly to the internet gateway. This is the opposite of the private one. This one requires a public-facing IP address to be able to communicate back and forth with the public internet through the internet gateway. So we can verify now that the routing is in place. Okay, perfect. The networking portion finally checks out, so we can continue building our AppStream deployment. One more networking component to consider is DNS. This is totally optional because your VPC has access to Route 53 to resolve public host names. But if you work for an organization that requires content filtering or at least some level of protection from well-known dangerous sites on the internet, DNS-based content filtering may be an option for you. Here we have OpenDNS, which is a service provided by Cisco Networks. And if we scroll down here to the bottom on the main page, it says that they're currently blocking more than 7 million malicious domain and IP addresses. I'll show you how to set it up if you're interested in using this service. Let's go back up to the Consumer tab, click on that, and then scroll to OpenDNS Family Shield. And then we're going to click on the Setup Guide button here. And here we are presented with the name server addresses that we need. We're going to leave this browser tab window open, and let's go back to our management console. I'll type VPC and select the service. This time we're looking for DHCP option sets, and we're going to click on Create DHCP option set. What we're doing here is selecting these two name servers and putting them in a configuration that is going to get passed into each and every host that we deploy in our VPC. So we can set other networking options, but we're not going to do that. We just want the domain name servers. Let's go back to our other browser tab. I'm going to copy the first value here. Copy. Then go back in here and paste the value. Use a comma as a separator. And then get the other value. Copy that as well. And then paste it. Perfect. We have the two values. We can scroll all the way down and click on Create. Let's go back to the main screen here. Let's give it a name. It should be this one right here in the middle. So let's give it a name. Open DNS filter and click on Save. It's a good practice in AWS to name your resources. Now let's go back to our VPC. Our VPC is already selected. If not, make sure to select it. And then we're going to click on Actions and edit DHCP option set. Now we're going to pick the one we just created, Open DNS filter right here, and click on Save Changes. With this change now complete, if we deploy an EC2 or an AppStream instance within our VPC, it will use those domain name servers, which will provide us with content filtering and security. All right, it's time for a challenge. So far, we have deployed quite a bit of resources in AWS without any actual validation. This can make finding issues later so much more complex. So for your challenge, go ahead and deploy an EC2 server. It can be Windows, Linux, doesn't matter. Log into this server via SSH or remote desktop, and then verify outbound internet connectivity by connecting to LinkedIn.com. Also, let's verify DNS-based filtering by visiting welcome.opendns.com. And lastly, don't forget to terminate your EC2 instance when you're done. So if you're ready to take on this challenge, go ahead and give it a try. It should take you about 20 minutes to complete. And up next, I'll show you my solution. All right, here's my solution to this challenge. Here in the console, I'll type EC2, and I'm going to start by deploying a server. I'll scroll down and click on Launch Instance. And I'm going to stick with Linux here. You can choose Windows if you prefer that. T2 Micro is fine for our purposes. So next, and make sure you select the proper VPC here. In this case, AppStream VPC. And since we need to connect over the public internet, so we're going to be choosing the public subnet we created, and make sure the auto-assign public IP is enabled for the same reasons. We need a public IP address so that we can connect to this host from our personal computer. I don't think there's any other changes in this screen. So next, 8 gigabytes of storage is more than enough. So next, let's give it a name. Call it name here and AppStream. Let's see, AppStream VPC test. That should do it. Next is suggesting this security group, which is port 22 for SSH from any source. And this is fine for our test. If you are doing Windows, you would choose RDP from this list, which is a different port. And that's what you would do if you were using anything other than Linux in this case. Windows, I believe there's an option now for Mac OS, but let's stick to Linux and Windows for our example. I'll go back to SSH and click Next. Now, this is just a confirmation screen, so launch, and I'll choose one of my SSH keys and acknowledge, and click on Launch Instances. And the machine is now in pending state. Let's wait for it to switch to running state. All right, with our machine now in running state, let's go ahead and select it. And if we go down here to networking, we can see that it has a public-facing IP address. Let's go ahead and copy that value. And we can now go to our command prompt to SSH into this machine. So let's go to command prompt. Here in the command line, I'll type SSH, EC2 user, @ and then paste the IP address. As you can see, I can connect without specifying the SSH key. That is because my SSH key is the default in this computer, so it already uses that by default. So I'll select yes here, and we are connected. So by itself, just by connecting to this machine, it proves that we have inbound internet access into it, so that's good. I'll try a ping linkedin.com. Let's see. And we get a response. That's good. That means we have connectivity both inbound and outbound. No issues there. We need to verify one more thing for the challenge, and that is I'll do a curl to go to a website, https welcome.opendns.com, and let's see if we get an actual HTML page here. And sure enough, if we get this response, that means everything is working fine. So we are configured and good to go. We have DNS-based filtering. We have inbound and outbound internet verified. So everything we've done so far from the point of view of networking is done. Before we finish this challenge, let's go back to our console. Back here in the AWS console, let's not forget to terminate this resource because we just wanted to do a test. So make sure it's selected, go to state, terminate instance, and confirm. And that concludes my solution to this challenge. Okay, finally we're ready to start producing an AppStream image that we can use for our demo deployment. Let's take a moment to see where images are found and how to manage them. I'll make sure we are in US West 2, Oregon region, which is where I did the VPC deployment. I'll start by typing AppStream and selecting the service here. By the way, you might end up in a page that looks like this. The reason is they want you to set up a quick and dirty sample so that you can test AppStream. But since we are doing an actual live setup, we can safely skip the screen. And from here, from the main AppStream 2.0 console, I'll go down to images. And you'll see a list of images here. You
You see graphic design, Windows Server 2012, 2016, 2019, and so on. The visibility here is public, meaning these are available to anyone that uses this service. Now, I'm going to select one to show you the available actions here. You have copy, delete, share, and update. Let's cover those now. The use case for the copy image command is when you have software that's deployed. Let's say you have a copy of Adobe Creative Cloud in an AppStream image, and you might want to update your software at some point. Before you do that update, you might want to go ahead and create a copy just in case something goes wrong. Then you will be able to revert back to that copy. So that's a use case for the copy command. The delete command in this case would be used to eliminate any excessive number of images that you may have here after several updates and deployment. Anything that you may no longer be using, you would just clear them from here with the delete command. Now, the share command, if you have an AWS organization where you have several AWS accounts, you may want to share your images across accounts. One use case is if you have a development account and a production account, you may want to just copy the approved version from dev to prod in this case using share. Now, update is not as magical as it sounds. It's not going to magically update your software, but it's going to update any necessary Windows patches or the AppStream software itself. Moving on down here, like I said, you have several options. You see that it says graphic design, G4DN. We're going to get into what those mean when we're talking about image builder. But for right now, I just wanted to show you the various options you have when managing images. And that's all you need to know about images, really. They're essentially files that you have to manage and keep updated. Let's go ahead and set up an image builder now. All right, it's time to launch our image builder. Before we do that, I'm going to show you these browser tabs that I have up here, starting with this one. This one is from Autodesk, and they make a software called Fusion 360, which is designed for CAD modeling. This is what we're going to use for our demonstration. The reason why I'm showing you this page is because it says System Requirements for Autodesk Fusion 360, and we need this information in order to provision our image builder correctly. I'll go down here, and you'll see, okay, it runs on Microsoft Windows. We got that. For CPU type, it needs 4 cores, 1.7 gigahertz or greater. We need to keep this in mind. For RAM, we're going to need 4 gigabytes of RAM or a little bit more if available. And this is the important one. We're going to need a dedicated GPU with 1 gigabyte of video memory or more. So let's just keep these requirements in mind. We're going to close this tab. This page that we're looking at now is the Amazon AppStream 2.0 pricing. And I'm going to scroll down here to show you the available options. You have general purpose for your everyday applications. You have compute optimized for something that is more compute intensive. And you have the memory optimized if you need a lot more RAM than compute power. If you keep scrolling down, you're going to see graphic G4. And if you look at here, it says you have 16 gigabytes of GPU memory. That's a little bit too much. We would be overpaying if we choose any one of these. If we go down, we have graphic design, and this is where I wanted to get you here. If you look at this, you have GPU memory, 1 gigabyte of video RAM, which is exactly what we need for the application. However, if we choose the first one here, the graphic design large, we're going to come up short because we just said we need 4 cores of CPU, and this one has 2 and only 8 gigabytes of memory. So we're going to go down and we'll see the second row that says graphic design extra large. And this one has 4 vCPUs, roughly 16 gigabytes of memory and 2 gigabytes of video RAM. So this is the most appropriate for our application. So now we just need to remember the name, which is graphic design X large. I'll close this tab. And now back here in our AppStream console, we can choose images, image builder, and then click on Launch Image Builder. Now you'll see you'll have various options. You see graphic design, graphic G4DN, graphics Pro, and so on. We'll stick to graphic design and scroll all the way down to we see the next button. We'll give it a name. We're going to call it Fusion 360 Builder. And we said we're going to choose Graphic Designs X Large. So we'll select it and then click on Next. Now, since we already have the networking, we can just choose our VPC, which is pre-selected right here, AppStream VPC. And in this dialog, make sure you select the private subnet, which would be the second one, 10.10.1.0/24. And the security group default is just fine. Now let's go to review. We get a warning that says we're going to be charged for the time that the image builder is running. That's fine in this case. The rest is just a confirmation of what we've done. I'll click Launch. And now we get back to our main screen with the builder that says pending. We need to wait for it to come into running state. So now we wait. All right. Now our builder is in running state. If we select it here and choose actions, you'll see that we have start, stop, delete, and create streaming URL. For right now, the action that we're interested in is connect. So we're going to click on connect here. And we end up in a different browser tab, which is essentially the desktop. We're going to choose administrator access. We have several users, as you can see in this machine. We're going to choose admin for now. Admin is the only user in this account that will allow you to install new applications. So keep that in mind. And we end up in a normal Windows desktop, except for this bar on top, which is the AppStream bar. You can see we have access to files. We have a clipboard. We have some settings such as microphone and screen resolution. And we have a way to switch from the admin user to other users' accounts in this same box. The rest is just a regular Windows machine. So we're finally connected to our image builder. We have the normal Windows desktop and we're ready to start installing application. So let's get to it. All right, it's time for your next challenge. With our image builder up and running, you can go ahead and install the application of your choice and then generate an image using the AppStream image assistant. I will be installing Fusion 360, but feel free to do this challenge with the application of your choice. For example, Paint.net is a nice and easy install that you can try and is not as complex as Fusion. You have 60 minutes to complete this challenge, not because of complexity, but because the image building process takes a significant amount of time to finish. So give it a try, and when you're ready, come back and watch my solution. Let's take a look at my solution to this challenge. I went ahead and installed the program Autodesk Fusion 360 in this image builder here. I'm going to run it here for you. So you can see it runs and then we get to the login screen, which is enough for now. Now, I want you to pay attention to the image assistant. I'll click on this application here. And it's an application that's going to guide you step by step until you have an AppStream image. The first step is to add your applications. In this case, we just have one application. Let's go ahead and click add. And then it asks for a file name. Here's what I do in this case. I'm going to close this. I'm going to select the icon and right click it. And you see where we have target. We have everything we need here, which is the path and the file name. So I'll just copy that value. Then go back here and click add application. And I'm just going to paste the value from that shortcut and click open. This one is called Fusion Launcher, which is not very friendly. So I'll use the display name here to call it Fusion 360. Also, you do have the option of changing the icon. You see, this default icon is not great. So I could click it and then select the icon path. However, if you look at this, it requires the icon to be in PNG or JPEG format, which we don't have. So that's okay for now. I'll just click save. With this application in place, now we can click next. And now we go to the configure apps screen. In this case, what we're trying to capture is any settings that are specific to the application. Let me show you that. We need to go to the template user. So I'll click on switch user and select template user. Now, in this particular screen or in this Windows environment under this user, any changes that we do will be recorded as part of the deployment. So if I run the application here under the template user, it's going to do exactly the same thing. We get the splash screen and then we get the login screen. Now, it would be a mistake if I put in my login credentials here and then go back and generate an AppStream image, because then the entire fleet will have my login information hard-coded in there. We don't want that. So we're going to leave it alone. Any registry changes, anything that we do in this user environment will be saved as part of the snapshot. So in this case, we just need the application. That's more than enough. So I'll switch back to the admin user and continue the setup process. I'll click on Save Settings. We didn't do any settings at all under the template user, but that's okay. This still needs to go in there and take the snapshot of that particular user. With that step complete, now we end up in the testing tab. Essentially the same process. We're going to click on Switch User, and this time we'll select the test user. This is a Windows user in this image builder that doesn't have any installation privileges or anything like that, and it's going to get the values that we just saved from the template user. So in this case, I'll do the same. I'm going to run the image assistant. We'll see the application and then we're going to click on it. Make sure it's executing fine without any loading errors that might prevent the application from running correctly. As you can see, it loads. And this time I'm actually going to log in because this is the test user. So we want to make sure it's actually working. Now we're logging in here. Let's see if the application behaves as expected. All right, here we are. I'm going to create a sketch just to make sure everything is working. I'm going to select rectangle. I'm going to click Finish Sketch. I'm going to click E for extrusion. And take a moment to think about what's happening. I'm actually using a 3D modeling application that's running inside a web browser. This is amazing, especially if you have users that have a low power computer, such as a Chromebook, for example, and they need to run this application. They can do it remotely from anywhere using that low power laptop because the AppStream image itself is running on a machine powered by lots of RAM and GPU as well. Now let's go ahead and continue our image generation process now that we know that everything is working properly. I'll close and not save. All right, switch user back to the admin user. To recap, we added the application. We ran a configuration step if needed. We completed the test. It's working just fine. So we just click next. Optimize step is just to reduce launch time. So we're just going to click the application and launch it. And it says here, wait for your application to load and then continue. All right, application is loading and I'll click continue. That was easy. The next step is to configure the image. We're going to call it Fusion 360 image. We can add a description if we need it. If we have several applications or something that somebody else needs to maintain, then this would be a good place to put those values here. And any tags if you're using resource tagging within AWS. I'll choose next. And now we're ready to actually create the image. So I'll click on disconnect and create image. What's going to happen now is going to shut down this Windows machine and it's going to turn it into snapshotting mode, and that's going to take our image. As you can see, we lost connectivity and that's perfectly expected. I'll close the tab. I'm going to refresh this image builder tab here so I can show you. Now it says our builder is snapshotting. We cannot connect to it or do anything. So now we're finally creating our image. So what's going to happen now is this process is going to take anywhere between 20 and 45 minutes to complete. And that's my solution to this challenge. We're finally ready to create our fleet. The fleet is the collection of resources that is going to serve the application to our audience. Let's go ahead and set one up now. I'll go to fleets here in the AppStream console and then click on create fleet. I'm going to give it a name here, Fusion 360 _ fleet. and then next, and select the image that we just created, and next. Since we decided that X large is the appropriate size, I'll select that. For fleet type, you have two choices: on demand, which takes about 1 or 2 minutes when somebody tries to log in. Always on is going to be a little faster, but it's also a bit more expensive. So let's stick to on demand for now. For user session management, these defaults are perfect, so we're going to leave them alone. And for the capacity, 1 through 5 is perfect. We're going to talk about scaling a little bit more later on, but for now, 1 to 5 is enough. And for the streaming view, since we only have one application, we're going to leave it as application view. If we were to choose desktop, that allows the user to see the Windows desktop, and that may not be what you want. So most of the time, you'll stick to application view only. We'll click next, select our VPC, which is already selected here, and select our private subnet, just like we did for the image builder. It's great that we have the ability to specify a subnet number 2, even though we don't have it, but we know that we have that option for future expansion. We'll click next, and we get the review screen here, and we're going to click on create. We have to acknowledge here that there's going to be charges once we deploy this fleet. So acknowledge and click on create, and we should get a confirmation here pretty soon. And there it is, success. As soon as we hit create and get this confirmation, AppStream will start powering up the machines and reserving the capacity that we asked for. This should take about 10 minutes to complete. And once done, we'll be ready to set up our stack, which is the final piece of this puzzle. It's time to configure our stack, which is simply an association of settings and a fleet. Let's start by clicking on create stack, and let's give it a name. Be careful with this name because it is case sensitive. So I'll type Fusion 360 lowercase underscore stack. Select the fleet. We have the one in running state now, Fusion 360 underscore fleet. And select next. We're going to discuss the settings later, but you may have to choose Google Drive or OneDrive if the application that you're running generates files. In this case, I'm using Fusion 360, which is a completely cloud-based application, so everything I save will be saved in the Autodesk cloud, so I don't need any storage attached to my AppStream fleet, but this is something to keep in mind. I'll click next. These are some settings that you might want to tweak, for example, the ability to copy and paste, file transfer, or printing. If you have an application that provides sensitive data to the users, you may need to disable some of these. Application persistent, as I mentioned, is not necessary in my use case because it's a completely cloud-based application, but you may want to allow the user to save, Windows settings or anything that they might change around the application that they're using. I'll leave it on for now. This is just a review of everything we just looked at, and I'm going to click on create. And there you have it. Finally, we have an entire AppStream stack deployed with proper settings, scaling, a fleet, and an application image. We're finally ready for testing. There are a couple ways to test, and I'll be sure to show you both of those ways. The streaming URLs are temporary pointers to your AppStream environment, and they're designed for quick access when you need to test or configure something without having to go through an authentication mechanism. There are a couple of ways you can generate streaming URLs to access AppStream, and let me go ahead and show you. We go to the Stacks tab here in the AppStream console and select the one we just created. Now go to Actions and click on Create Streaming URL. You can give it any username here. I'll put CJ. You can configure the URL expiration. In this case, 30 minutes is fine. Click on Get URL. So this URL, you can share it with anyone. It will expire in 30 minutes in this case. For now, I'll just click on Launch in Browser. It will open a new tab, and we are presented with the AppStream screen here. I'll select the application. Now, this will take roughly 90 seconds to come online, so we wait. All right, As you can see, the application loaded as expected. I'm actually going to close the application. As you can see here, even if I right-click or try to do anything, we cannot access the Windows desktop because in this AppStream setup, we decided that it was best to use application streaming mode and not desktop streaming. I would need to go back to the AppStream bar here and select the application if I wanted to launch it again. And as I mentioned before, this temporary access URL would expire 30 minutes after you received it, and you can share it with any of your testing team members. Let's close the tab now. You can also share a streaming URL that points to an image builder. I'll go to Images, go to Image Builder, make sure our builder is running, and then select it, and click on Create Streaming URL. I'll do the same. Instead of copying the link, I'll just click Launch in Browser. The use case for this is when you have an application that is difficult to install or it requires many steps such as configuring license servers, activation keys, configuration files, or any post-installation steps. In this case, you would share the streaming URL with a subject matter expert that can help you get the software up and running, and then you can take back control and run the image assistant following the regular AppStream installation process. As you can see, we can log in just fine, and this URL can be shared. The person doesn't need to have a specific access to AWS. As long as they have this URL, they can access this image builder and help you with the installation process. Creating temporary URLs all the time for testing can get annoying. However, there is another option, and that would be to create a user in the user pool. These users will get a permanent URL that points to AppStream and credentials that they can use over and over. I'll go to User Pool here in the AppStream console, and I'll click on Create User. It is as simple as typing in an email, first name and last name, and clicking on Create User. I'm not going to do that now because I already did. Let me show you. I'll find the link that I got on the email, and I'll open a new tab and paste the link. I'll type in the email, and I'm going to paste in the password. Now it's logging in to AppStream, and we get an error message that says, your admin has not assigned apps to you yet. Okay, let's go back to AppStream. I'm going to select the user here and click on Actions, and it says Assign Stacks. We only have one stack, which is the Fusion 360 in my case. I'll select it and click on Assign Stack. Before I click on it, there's a checkbox here that says Send email notification to the user. What this means simply is that they'll get a notification that says you've been assigned to the Fusion 360 stack. It's probably not necessary if you're doing this for yourself or just a handful of test users that are already expecting this email, so you could probably get away with turning this off. I'll click Assign, and we get a confirmation. Now let's go back to the AppStream tab here. Let's see. I'll try the login again. Type the email and paste in the password. And now we get the application. I can click on it and access AppStream as expected. If you have, say, less than 10 users, this could be a good option to manage access to AppStream stacks. That said, it can become time-consuming if you have to help people with credentials, assign stacks, enable users, disable all users, and so on. So anything more than a few users and production use, for example, I highly recommend that you look into single sign-on options such as Google Suite, Azure AD, AWS SSO, and several others.
There is one very important operational factor that you need to remember around AppStream, and that's the issue of scaling. You see here on the screen, it says minimum capacity and maximum capacity. That's going to affect the pricing and availability of the service that you are providing. However, we can't really talk about scaling until we talk about the actual limits. For example, let's say it says here maximum capacity. I could set this value to 500, and then my fleet will have the possibility to scale up to 500. However, by default, Amazon is not going to allow that. So let's go ahead and fix that problem first. I'll go up here to the search bar and type quota, and then click on service quotas and look for AWS services and find AppStream on this list. Now, if you remember, we have Stream Graphic Design X Large. That's what we're using. Let's go down the list here. We see Graphic Design X Large streaming instances for Image Builder. That's not what we need. We are happy with our Image Builder. We're looking for Graphic Design X Large streaming instances for fleets. Okay, so we're going to go ahead and click on this. The default, as you can see, is 10. In other words, for your protection, you're never allowed to launch more than 10. But what if I have 500 students, or I have 150 employees that need to access this AppStream service? There's a button here that says Request Quota Increase. They're just going to ask you for the number. So we can say 100 and just click on Request. What this is going to do behind the scenes is open a support ticket with AWS, and you'll get an email on your AWS root account email saying, hey, this request was placed and now we're processing it. Probably they'll get back to you asking for a use case, and then you can say, well, I'm trying to use this fleet to run this graphic design program or something like that. And soon thereafter, you will be approved to use your 100 instances or whatever the number may be. So keep that in mind. With that out of the way, let's go back to AppStream and have a discussion around scaling. We're going to go to Fleets, select our fleet, and then go to Scaling Policies. You see we have these two values here, minimum of 1 and maximum of 5. These values are great starting points, but they're not great for managing day-to-day operations. Let's take a look at these two policies, one that says Scale In and the other one Scale Out. And these are defaults, so keep in mind that you can change this to fit your needs. We're going to click Edit here to take a look. This is the default Scaling Out policy. Let's just read it as it is. It says, if capacity utilization is greater than or equal to 75%, then go ahead and add 2 instances to the fleet. Now let's see what we can change here. Let's see this pull down here. It says utilization, available capacity, and insufficient capacity. Let's click on this one. It says insufficient capacity. What this means is you have people logging in and they're getting an error message that says there's no more machines available. So if this error appears, let's say greater than or equal to 2 times, then go ahead and add 5 instances. Or if you wanted to grow your fleet a lot faster, you could say go ahead and add 25% capacity. So that way you can scale out a lot faster. This would be a great use case if you have a lot of people coming in for an event and then they're going to go away. You want to make sure that you have capacity and scaling policies to handle that traffic. I'm going to cancel this change here. I'm going to show you the scale in policy now. In this case, we're doing the reverse. We're looking for machines that are not being used at all so that we can discard them and scale back to a normal size where we're not paying too much money for machines that are not being used at all. So again, if capacity utilization is less than or equal to 25%, go ahead and remove 1 instance. If you want that to happen faster, you can remove 2 at a time. You can remove 5 at a time, depending on the size of the fleet. Or you can do that based on percentage, remove 10% of the capacity all at once, for example. This really becomes powerful when you combine all this with schedule scaling policies. The best use case for these policies is when you want to make a distinction between weekdays and weekends. So we're going to call this policy weekday _policy. And I'm going to put a date here. I'm going to choose 01/01/2020. And in here, I'll put 01/01/2050. Think of this date as effective dates. In other words, this policy will only be valid within these 2 particular dates. They have no effects on the scaling. They just need to be used to be sure that this policy is active or not within this time frame. Now, for minimum capacity, let's say I want the minimum to be 40 because I'm expecting a lot of people at the beginning of the week. And it could be up to 100, for example. Now, there's one problem here because you have once, which is not what we want. We don't want a one-time event. We could say frequency but then the frequency formula here is very simplified. So I could type a number here and select the unit, which would be minutes or hours. Again, this is very simplified. It will not work for us. What we need is a cron expression. I'm going to paste one now so that you can see that. This cron expression means at 8 a.m., 8-0, go ahead and execute this policy and set 40 and 100 as long as it's Monday through Friday. And keep in mind, these times are UTC, so you will have to do that conversion based on your time zone. Now, if you don't understand this cron syntax, you can always click on this cron syntax here, and it will give you the meaning of each field. And even this is not necessary for you. You can just scroll down and you will see examples here that you can choose. For example, there's one Monday through Friday here that says 18-0, which is 6 p.m. And it tells you exactly what it's doing right here. Run at 6 p.m. UTC every Monday through Friday, for example. You can just copy these values. I'm going to close these tabs and get back to our screen here. And for example, if you wanted a policy for Saturday, Sunday, you would just change this right here and type SAT-Sunday. And then because there's not much activity going on for this fleet during the weekend, I would set this to minimum of 2, for example, and a maximum of 5, let's say. And this is how you set it up using this formula. Of course, you would need 2 separate schedule scaling policies, one for the weekend and one for the weekdays, in this case, if you wanted to use this approach. Whenever you change the minimum and maximum, that's what it stays. In other words, AppStream is not going to remember whatever the value was. So it's up to you to control these values using policies. What I do is I just use the policies that I just described, the schedule policies, set the values that I want based on day of the week or hour of the day, and then allow the default scale out and scale in manage the fleet from there. After all, for example, if it's Monday morning and I have 40 machines available to everybody and then nobody shows up because let's say it's a holiday, the scale in policy will slowly take care of reducing that fleet slowly one by one until the fleet is completely depleted. So that's all you need to know regarding scaling. It's a very interesting topic because there's a fine line between providing availability of the fleet to your audience and also budgeting and not paying for an AppStream fleet that's not being used. It's a very delicate balance that you have to learn over time as it evolves and the usage of your fleet grows. Let me show you how to keep track of settings and files for your users across their sessions on AppStream. We'll go to Stacks. We'll select our stack, and let's talk about storage first. In here, you have 3 options. Home folders, which is simply mapping the user's files and home folder to an S3 bucket. And when they come back again in the future, these files will come back from S3 to the home folder. So the AppStream machine, even though it's a public computer from the fleet, it will look exactly the same to the user in this new session. Another option, and this is the one I recommend, is to use Google Drive. You just have to specify the domain here, and once the user logs into Google Drive, and then when they come back in the future, everything will remain synchronized. The same can be said about OneDrive. You just specify the domain here, the login with their credentials, and anything in OneDrive will map to a local folder within the home folder of this particular user. Now, let's talk about user settings, because you don't want to have to log in over and over again to Google Drive or OneDrive if that's where you're connecting. The way to avoid that is to persist the settings across sessions. You do that by going to User Settings, Application Settings, and clicking on Edit. In this case, it's already enabled, but what this does is it will keep track of changes that the user may have done during their working session. So next time they log into AppStream in the future, even though they will get a different brand new machine, they will have their settings persisted in an S3 bucket and they will come back and be loaded in time. So even though AppStream virtual machines are essentially disposable computers that get refreshed every time a user logs in, having setting persistence on
in addition to one of these storage options, it would feel more like a virtual desktop experience that belongs to them as opposed to a public computer. So now we need to set up single sign-on. We really can't do that because that's a little bit outside of the scope of this course, but I'm going to guide you to the steps that are necessary for pretty much any provider, whether you're using Google Suite, Azure SSO, or AWS SSO. So let's start with identity provider. In here, all you really need to do is upload the metadata that's given by your provider so that AWS can establish a trust between your provider and this access that we're trying to set up here. And you can do that by coming here to IAM, selecting identity provider, and then clicking on add provider. Make sure you have SAML selected. You give it a name, and then here where it says choose file, you can upload the metadata XML file provided by your IDP. Usually the most popular that I've seen is Google Suite for people that need to add AppStream to their Google Suite environment. Now, once they go through here, they will need a role with a policy. Let's talk about the policy first. I'll go to policies here on IAM, and I'm going to type stream _ only policy, because this one I just created, and I'll show you. I'll click on edit here so I can show you the exact policy. It really only has one feature, and that's the stream feature of AppStream. So this is perfect because people will be able to stream. They can't make changes to AppStream, nothing around scaling or changing anything, just stream their application. This is a perfect policy for all your users. I'm going to cancel out of here. Now I'm going to go to roles, and I believe I already have one set up called AppStream Access Role. And yes, this one has the stream only policy attached to it. And there is a trust relationship. I'm going to click here. And there is a trust between the IDP that I set up, in this case, Google Suite SSO, and this role. What this means is anybody that logs in from Google Suite SSO will go through this role and it will get the permissions that we established, in this case, the stream only policy. Now, we're not going to configure the side of your IDP. As I said, this is outside the scope, but just keep in mind that you're going to need this role ARN. Let me show you my guide here. This is the AppSpring 2.0 administration guide, and it has the steps. So far, we've done step 1, create an IDP. Step 2, create a federation IAM role. And 3, embed the inline policy for the role. So we already have 1, 2, and 3. We're going to go over real quick over 4, 5, and 6. Let's click on 4. It essentially says get the metadata and upload it. That's perfect because we already did that. That means we are good through the first 4 steps. Now step 5 says create assertions for the SAML authentication response. Let's take a look. These are the values that are expected. In this case, the name ID or the email of the person logging in. The subject type, which is, in this case is a value of persistent. This is a constant value, so you don't need to worry too much about that. And it's already probably defaulted just like this in your IDP. Now, for the role, you're going to need the ARN of this role and the ARN of the IDP. Let me show you where to get that. We're looking at role here. This is our AppStream access role, and the first value at the top is the role ARN. In the same fashion, you would go to IDP, click on your IDP, and get the ARN. And this is the value that is going to go here under role. You also have role session name and session duration. I believe these are values that you default or just set to something that's specific to your use case. In this case, the default value is 60 minutes. You may have a different use case, but again, these are just attributes and constant that you set as you go. Going back to the top here, let's see. Now we have step 6. This is what I consider to be the most important one because it provides the URL that you're going to need from your IDP to come to the AWS side. The reason why you need an URL is because we don't need our users to know they're running in AWS. They don't need to see the AWS console or have anything to do with AWS at all. They need to go from your IDP after they log in directly to this link, which will take them to their application on AppStream. Like I said, they wouldn't even know they're running in AWS. And the way you do that is by providing this relay state URL. This URL has several components. Let's go over them. The first is the endpoint. The second is the stack name, which is, in my case, is Fusion 360 stack. And the account number of your AWS account. Now, we know this last two values. What is this endpoint that we're talking about? Well, it is provided down here on this table. And since we're using US West 2, the endpoint will be this value right here. AppStream 2.us-west2 and so on. So you take this string and you put it right here, and that would be the value for that. So there's no reason to memorize anything. Every step I just completed is right here on this guide. I'll scroll back to the top to show you. Is the setting up SAML section of the AppStream 2.0 administration guide. And it'll guide you through this 6 steps to set up your specific SSO. Whether you're using Azure AD or Google Suite, the steps are going to be essentially the same. And in fact, some of those are already coming baked in with solutions for AppStream. So you can just go in there and say, hey, I'm trying to set up an AppStream, and they'll have a similar step-by-step wizard like this that will guide you through the necessary steps that need to be completed to configure SSO. I hope this helps you setting up SSO for your AppStream solution. One question that I get all the time is, what do I need to do to update my fleet? Well, let me show you. If we go to Images and Image Builder, let's say that you have your image builder here. You haven't used it for months. Probably it's going to be in stop state. You can select it and go to Actions and start it from here. Once it's started, then you can click Connect, just as we did earlier. And then you'll be presented with the machine like this. I'm going to run the Image Assistant. And then let's say that, we just updated Fusion. We want to add additional apps. Let's say that we want to add this application here, Firefox. I'll just right click it, click on Properties. I'm going to copy this target, and I'm going to click Add App here and paste the target. I'll click Save. So we have this additional new application. All we need to do is go through the standard process, configure, test it, do the optimize step, and generate a new image. By the way, you need to generate a completely new image with a new file name. It will not let you overwrite an existing image, so keep that in mind. Once this process is complete, you will be back here, and you'll go to the image registry. Actually, I'm going to filter on private here, and there will be an additional image that you just created. Now, what do I do with this image? You'll go to Fleets, and under Fleets, you'll see that your fleet is either running or not, depending on usage. You can select it, and then under Fleet Details, you can click on Edit. And there is an opportunity here for you to change the image and just click on the Update button. This is known as a rolling update. So what's going to happen is, as soon as a person logs out, if they try to log in again in the future, they will get the new update. Let's say that doesn't work for you and you want the change to take effect immediately. Well, in that case, you will select the fleet, go to Actions, and then stop the fleet. And then once the fleet is stopped, you can then click the Edit button, just like we did a moment ago, select the new image, and then click on Update, and then finally go back to Start here to kickstart the fleet. In this case, you'll have the image take effect immediately with the updates. But in this case, you're creating a downtime situation. So any users that may have been working on the fleet at the time, they will be logged out. So those are your two options for updating a fleet. Once you start using AppStream, you realize that it's not meant to be an end-all, be-all solution to every problem. One quick example is persistence of the desktop experience. If you need your users to have a desktop that works exactly like a physical machine in their office or school, then Amazon Workspaces is probably more appropriate because the virtual machine assigned to a user stays with them for as long as needed. Whereas AppStream will create a new machine on each and every login attempt. Another reason will be the operating system. Workspaces support desktop operating systems and AppStream does not. So applications that are very specific to a Windows version would have trouble running on AppStream. In fact, if you need a Linux desktop, then you are forced to use Workspaces because AppStream does not support Linux at this time.
One thing you may find better about AppStream is that since you have a single machine image to maintain, it's easier to enforce compliance as opposed to workspaces where you have users that have flexibility about what to update and when to do it, just like a regular desktop computer. Domain joining is more intuitive in workspaces since it was made for that purpose. It is possible to do it on AppStream, just not as simple. And finally, to summarize, remember that you always have alternatives, whether it's AppStream to deliver applications, workspaces for that familiar desktop experience, and also individual EC2 servers that people can remote into, which gives you the most flexibility and control, but also comes with the highest overhead and maintenance costs. Before installing any applications on AppStream, I encourage you to look for installation guides, as this will eliminate any pain points specific to AppStream. Using your favorite search engine, for example, you can search for application name plus the keyword AppStream. I was able to easily find these guides you see listed here. In fact, I don't recommend that you even try to install Adobe Creative Cloud on AppStream without reading this guide first. One more link before we go. Here's where you can find the official administration guide for AppStream. If you get stuck, this is probably the first place you want to check, unless it's application specific, in which case I'll refer you back to the installation guides. Lastly, if you want to connect, or if I can help you in any way with your implementation of AppStream, feel free to reach out on LinkedIn. And remember, even when stuck at home for long periods of time, always keep learning and keep pushing forward. I'll talk to you on my next course.